In Unit 3, Section 2, we have equations as relations. All right, and then this next set of problems, well, and this is always the case, make sure you read the directions. The directions here say to determine which ordered pairs are part of the solution set for each problem. So what I'm going to do is I'm going to start with the original equation, y is equal to 2x plus 3. I'm going to take each of these 4 points. So this is actually a 4-part problem. I'm going to take each of those 4 points and plug the coordinates, -2 and -1, into the equation. So the -1 goes in for the y, the -2 goes in for the 3, and what I want to know is, does the left side end up equaling the right side? Number 1, it does. The second point does not, the third point does not, but the fourth point does. So your answer here, the solution set would be those 2 points that end up working, -2, -1, and 3, 9. Likewise, for the next problem, we're just here to see which of these 4 points satisfies this equation. So we write down the equation like I did here. Each of these coordinates goes into the equation, so we have 3 times 0 minus 3 is equal to -4. Does that equal each other? And in number 1, it does not. But the next 3 do. They do work out. In the second one, 6 minus 10 is equal to -4. -6 plus 2 is equal to -4. 0 minus 4 is equal to -4. Those 3 work. So your answers here would be those 3 points, 2, 10. -2, -2, and then 0, 4. And then the last set of problems here, it's just asking you to solve for y. Again, always make sure you're reading the directions. Do what it asks you to do. So we're solving for y. To do that, what we need to do is cancel out a positive 3x from the left side. It'll take a negative 3x to do that. And on the left side, we end up with our y. On the right side, we end up with this negative 3x. It comes first. Whatever the x term is, I want it first. And then it's a positive 4, so it's plus 4. In number 2, I need to cancel out the negative 2x. So to do that, I need to add 2x to both sides. That leaves you with the opposite of y here. Negative y is equal to whatever the x term is, I want it right after the equal sign. So we have 2x. It's a positive 3, so 2x plus 3. But the deal is, though, on this one, this has a coefficient of -1. So I need to divide through by -1, divide all the terms by -1, and get y is equal to -2x minus 3. In number 3, I want to cancel out the positive 2x from the left side. It'll move it over to the right side. Again, the negative 2x is going to come right after the equal sign. I have a positive 9, so it's plus 9. I needed to get rid of the coefficient 3, so I'm going to divide through by 3, and I get y is equal to -2/3 x plus 3. In number 4, this is a positive 4x. Now, here's the danger in this one. A lot of people want to look at that minus sign, the minus 2y, and say, well, we're subtracting here, so to cancel it, we need to add. Well, that's not the case, because this is a positive 4x. The minus sign goes with the 2y. It's a positive 4x. To cancel it, we need a negative 4x. So we do minus 4x to both sides. What we're left with is negative 2y is equal to negative 4x minus 6. I divide through by -2, and we get y is equal to 2x plus 3. All right, now we're going to solve each equation using the given replacement set. I suppose we should replace replacement set with the given domain. If you would, make that adjustment. With the given domain, meaning this. Here's our domain. It's the set of x's. So what x's am I going to be using to solve this equation? What that means is we're going to make a table where we're going to put these numbers in the x column. So I'm going to have -3, -1, 0, 2, and 4. The next column, now listen carefully, it's whatever y is equal to. What's y equal to? x plus 5. In other words, here we need to solve for y. Whenever in doubt, solve for y. And now all I'm going to do is plug in my negative 3 in for the x. So it's going to be negative 3 plus 5. And then I'm going to have negative 1 plus 5. 0 plus 5. 2 plus 5. And 4 plus 5. What is negative 3 plus 5? Let's figure this out. That'll be equal to positive 2. Negative 1 plus 5 is 4. 0 plus 5 is 5. 2 plus 5 is 7. 4 plus 5 is 9. So what are the ordered pairs going to be then? It's going to be negative 3, 2 is my first ordered pair. Negative 1, positive 4. Then I'm going to have 0, 5, 2, 7, and 4, 9. Now, at the beginning of the class, we talked about how what the definition of linear equations is. This is a linear equation. And what would happen if we plotted these points on the coordinate plane, they would line up in a straight line. We're going to see that on the next problem here. Following equations, plot the solution on the coordinate plane. Now here's the domain that we're going to be using. So I have my set of x's. Those numbers are going to be negative 4, negative 2, 0, 2, and 4. What do we put in the next column? Right, it's whatever y is equal to. What's y equal to? 1/2 x plus 1. When I figure that out, I'll be able to determine what y is, and from there, I'll have my points x and y. So I'm going to go 1/2 times negative 4 plus 1, and then 1/2 times negative 2 plus 1. Then 1/2 times 0 plus 1, and 1/2 times 2 plus 1, 1/2 times 4 plus 1, and I'm going to figure out all these problems here. Well, I get negative 2 plus 1 is negative 1. I get negative 1 plus 1 is 0. 1/2 times 0 is 0. 0 plus 1 is 1. Half of 2 is 1. 1 plus 1 is 2. Half of 4 is 2. 2 plus 1 is 3. So I have all these points. Negative 4, negative 1. Negative 2, 0. 0, 1. 2, 2. And then 4, 3. So we go over here to our graph and we plot these points. Negative 4, negative 1, 4 to the left and 1 down. Negative 2, 0 would be 2 to the left, 0 up. 0, 1 would be 0 to the right, 1 up. 2, 2 is 2 to the right and 2 up. 4, 3 is 4 to the right and 3 up. And as you can see, these points line up in a straight line. Now, what would happen if they didn't line up? Then you would know that you have made a mistake. So always keep that in mind.